All right, so today, let's see if we can take a shot at adding in the intermediate step of the geometry shader. So, see if we can remember where we're at. I'm gonna quit out of my terminal, form a new terminal. So here's where we are. So we spawn it. Let's see. Just trying to get to my creator. There we go. All right, so here we are. The other day I added a little bit of additional stuff. So you can see now it's rendering it with colors. And you can see that what it's actually doing is it's taking the max. I also added, it doesn't attenuate, but I do check the radius. So we're not getting squares anymore unless the pixel size is really small. Now it's using GL points right now. We don't want to use GL points in the end. We want to use quads, or we want to use triangles that form quads. So what we're going to do, we're going to work on this a little bit. One of the big advantages that we're going to see as we move towards using quadrilaterals generated by triangles, is we're going to see that we can do things in coordinate space. So here we'll do particles.geom.glsl. So now we've got this new shader here. So this current shader that we're taking a look at is generated from the is what we use to turn points and DXs into grids. So we use this inside the block rendering system. We're going to use it here instead to generate triangle strips. Now I always have a hard time remembering the right way to do the triangle strips, the right order, and all that stuff. And we're going to have to pass through a whole bunch of things. So what you're going to see is you're going to see me probably struggling just a little bit with some of this stuff. So let me close down some of my windows, get a little bit more organized here. And the basic idea behind this is that we are going to feed in to the geometry shader a smaller number of values, and then it is going to emit new vertices. So the way that it's set up right now is inside our vertex shader, we've got our V model, gets our model vertex, we generate our inverse projection, inverse model view matrix, inverse projection model view matrix, and right now we are using GL position, which is the projection times model view times the model vertex, and so that gives us, converts from our world space into our vertex coordinate. And here you'll note that I'm also doing this GL point size. So that's for rendering GL points. We're going to eventually get rid of that because this is specified in pixels. And because we're trying to render physical objects, we want this instead to be specified in something that's relevant to the world coordinates. So the reason we do that is we want to be able to use this to render both discrete point particles and also particles that are part of a Lagrangian approximation of a fluid. So these are particles where they have some sort of sample region, that's around them, and then we want to have some kind of an additive system that generates them. And all of the coordinates there are going to be in world space coordinates. They're all going to be in physical coordinates that are relevant to what we're looking at. So we want to be able to do our calculation in physical space coordinates. So our particles, we are going to, from one point, generate out a triangle strip. which is going to approximate a quadrilateral. So the number of vertices that we need for that, let's see, I can never remember because we're doing the triangle strip. I don't remember if it gets closed or not. So I think what we want to do is we split this into 6 maximum output vertices. So layout, we get 1 point that's in. We get an in vector. And so a lot of these in vectors are things that are for the grid. And we're not actually going to be doing any of that stuff. We're going to get an in float, which is our radius. We'll say vertex radius. So here we will say v radius equals in radius. And we'll go ahead and multiply by scale because we may end up wanting it to be in a scale. And here we'll take a look at our grid position vertex just to see how it's, the various different things it's doing. You'll see it's specifying all of its vertex outs here, so let's specify flat out v radius. We've got our field value that goes in, but the field value we're going to have to pass through, so we'll probably have to deal with that in just a moment. Excuse me. Happy Saturday, right? I'm going to pass this through here. We don't need our left edge, right edge, dx. We are going to need our inverse projection. Well, we may not end up needing it, but we are going to ask for them. We're going to ask for our camera position. Maybe not. Right. Yeah, one thing that I always get confused on here is the way that we have to specify a variety of different outs. So our outs here, our grid position, each one of these is for a vertex, and then we get new vertex values. We have to emit those for each of our sub-vertices. And so let's take a look again at our particle fragment. It doesn't actually get very much, it just gets field value, V model, and so we're going to have to emit each one of those. So inside our particle V, we're going to do VV radius. We are going to do flat out. We don't actually get a V model. We do get flat out of each one of these. And I'm prefixing them with V's so that we know that we're going to strip that V off inside the geometry shader. Now let's take our inverse projection. It's going to be V inverse projection, V inverse NVM. Geo position is projection times model view times model vertex. V model, I'm going to make that VV model. Because each one of these, yeah. So these are going to be arrays. They're going to have a length of 1 because we're only receiving one point in and then emitting our triangle strip, but we still have to regard them as points. Oops. our V radius, our V field val, and we're going to push these back out. So all of our ends here now come in as arrays. They're all going to have a length of 1. If we take a look at our grid vertex, grid geometry shader, see that all of the different things here. So for instance, our ends VDX, even though there's only 1, they still come in as arrays. So that's what we're going to be managing here. So inside our vertex shader, so we've got our V radius, we can probably get rid of this, but we'll do that in a moment. So let's get back down to here. So our center, so our position, we'll call this our position, is GL in 0, GL position. We only have 1 coming in, and we're going to expand it into a quad that encompasses the circumscribed projected radius of the sphere. Our new position is probably, no, it's not going to be identical for each one. We're going to generate 6 triangles. So the first one, we're going to do this in, we'll write this all unrolled. So our first one is going to be the upper left attribute of the quad. So here, that's going to be so we have 8 corners to our cube, which we are projecting down into, which circumscribes the sphere. We are then going to project our cube onto a 2-dimensional plane. So let's compute each of the 8 corners. We will then take the min and the max of each, which is going to give us a set of 6 points, and we will then use that to construct our quad. There's probably a better way to do this. So let's take our extrema position. For int I equals 0, I'm going to get rid of this for now. We're going to end up emitting a vertex, but we will do that a little bit later. I less than 6, I plus plus. So the first one that we're going to do is we are going to, each one of these is an arrangement. Oh yeah, and it's not 6, it's 8. This arrangement gives us our cube. New pos is equal to position plus, and position, remember here, is a vec4. Times radius. So this is not going to be exactly right. Oh, and this has got to be. So we actually want this to be GL position minus radius. No, that's not what we want. We want everywhere that this is 0 to be minus 1. Yeah. Because remember, the radius is going to be half of the side length. So that means that the very first iteration through here oops. that means the first iteration through here, we've got our position. That will be the center. Our new position, so the corner that we're looking at is going to be position plus the arrangement times the radius. So that means it will be minus 1, minus 1, minus 1. So we'll subtract off the radius from each one. We can now project this and get a vec2 or a vec4 from that. That gives us our position, and we will simply get the min and the max of the first 3 elements. So I'll have to do an element-wise min on that. New pos times, projection times model view times new pos. Do we get those in here? I think we must. Yeah, I think they're passed through already in my includes. So that gives us projection times model view times new pos is going to give us our position. So this is going to give us each one of our individual 4 corners. So we'll say vec3 left corner, vec3 right corner equals vec3. Do we get inf? Get a lot of fun items here. So we'll just say left corner is going to be position. Oh, you know what? This is GL info GL position, but that's not what we want. We want our position to be our V model. Yeah, there we go, V model. So let's take our V model as our position, because that's in world space. Our left corner will be vec3 of position.xyz. Right corner is going to be vec3 of position.xyz, because we know that that is not going to be the min or the max. Right corner is equal to right corner.x equals min. There's probably a better way to do element-wise here. Frag pos. Corner pos, we'll say. We're going to say corner pos is position plus vec4, arrangement with 0 times v radius of 0, right corner x, corner pos dot x. And this is actually going to be, we want the maximum. And then we'll do the same thing for left corner. But here, this is going to be our minimum. So this is not probably the most efficient way of doing this, but it is giving us our opportunity. It is allowing us to see the right corner is the maximum of this right corner or the corner position. And the right corner, corner of Y, so on and so forth. So this gives us our, when we come out of this, each one of these should now have our left corner and our right corner. So now what we're going to need to do is we're going to need to swizzle these into our new quadrilateral corners. So recall that if we have a corner up here and a corner down here, we can convert that into a set of 4 vertices by converting some of our items. And so we will say frag left corner is equal to left corner. And actually, you know what, let's say, it's going to make this a lot easier if we just use vec4s everywhere. So let's use vec4 here. Frag left corner equals left corner, projection times model view times left corner. Frag right corner, projection times model view times right corner. And these are going to have, because they're now going to be in fragment space, we're really only going to care about the first 2 coordinates of them. So we can say that our 4 vertices, recall that if we look at our Stack Overflow, the fastest way of converting a quad to a triangle strip, A, B, C, D is our quad. We can convert that into A, B, C, and A, C, D. So, say, we're going to ignore our Z values for this particular case, because our Z is actually what we're going to use for Z is we're going to take that from our GL position. Vec4a is frag left corner dot xy GL position 0. Here this will be frag left corner x, frag right corner dot y. No. We want this to be frag right corner dot x, frag left corner dot y. And we'll use those 2 again. C is going to be frag right corner xy. And D is going to be frag left corner dot x, frag right corner dot y. So, to emit our vertex, let's go back over here to our geometry shader so we can see the way that the grid expand geometry works. We need to emit each one of the uniforms that it's going to use. So first, GL position is equal to A. The other item that we need is let's take a look at our particle fragment. We also need our field value. So field value equals V field value. V model is equal to, and this should be VV model, I think. No, guess not. Yeah, VV model. Yeah, and then V field value and V radius. Okay, so V model equals VV model 0. Field value equals V field value 0. Radius equals V radius 0. And I think we can do emit vertex. I think we can just do this like this. That's 3, 4, 5, 6. So A, B, C, and A, C, D. So A, B, C, A, C, D. So this is likely not going to compile. It's probably going to have some other issues with it, but let's take a look at what we end up with. So now over here inside our shader list, let's go down to our particle content color fragment shader vertex. We're going to add another geometry shader. We're going to call this particles. Info expand particle from points to triangulated quads. Source particles.geom.glsl. Now let's go on down here. Looks like we've got these first geom. So let's go find our particle. First vertex, first fragment, first particle, and we'll call this particles. Yeah. Now inside our fragment shader, we're not going to be able to use our GL point chord here. So instead, let's just get rid of that. Now when we run, we're probably going to get some syntax errors. I have a tendency to write a lot of syntax errors into my shaders. And additionally, OpenGL does not allow swizzles on scalar expressions. That's fun. Okay, so we can debug this a little bit here. Operation ZW. All right. So VV model also has a syntax error. Let's try recompiling this. Oh, yeah, it's broken. Okay. Still no swizzles. Not present on operand ZW. Oh, and it's still not letting me recompile right inside, so let's go back here. We will expand this. So XY. GL position 0.z, GL position 0.w, .z, GL position 0.w. Alright, so let's get rid of the swizzles. Let's see what happens. Implicit cast from float to vec4. Oh, so I must have a much worse type problem than I'm seeing here. Oh. Of course. And I bet I could go and swizzle these again, but we'll deal with that in a moment. Oh, I've got a space here, that's going to cause problems. Make sure I've got this right, because I did make a change right before I relaunched it. Alright, one of the downsides to the way that I've got the includes all set up here is that getting the actual line number can be tricky. So OpenGL does not allow swizzles on scalar expressions. It's 105, swizzle mask not present in operand Z. Maybe I have GL position wrong. That's a vec4. Well, you know what? Maybe the better thing to do here be to have it print out the full line that it's erroring on, but alright, let's see. Line 90. Can't be that because we're not doing anything on line 90. So let's look at my known uniforms.include. This is 42 lines. So now let's go back. This, so 42, so that should be line 48. It doesn't quite do it. Alright, so let's take a look at our shader objects. Self.compile. Let's see, where is this coming out? Print exe, so that's printing the exception. So def compile, it's compile shader. We've got this shader source. So let's try oh, you know what? I've got self.shader source. So print that self.shader source. Let's make sure that this does what we want it to do. It should print out both things. And if it does, then we'll figure out which error line it all comes out on. There we go. Alright, so it is giving it to me. So we want to see the line number. So instead, what we're going to do is we're going to say, we're going to get a temporary log or something like that. Enumerate this. Do print f line num 05i line. That should do it. This might throw a binary versus string error, but we'll see. Still not that great with format strings. With F strings. I'm okay with format strings. Not amazing, but okay. Alright, so let's go back up here. Invalid type. Line 105. vec4b is vec4 far right corner. Frag right corner, frag left corner, GL position 0Z, GL position 0W. Oh, but actually this should be line plus 1, shouldn't it? Yeah. Because one's going to be 1 index, the other's going to be 0 index. Oops. Line num +1. Okay, let's go back up here. OpenGL does not allow swizzles on scalar expressions. Is GL position not a... GL position 0. Let me take a look at my grid. Maybe that's the whole problem. Oh. Ah. I was doing this the wrong way the whole time. But at least I got some nice quality of life stuff out of this. So we've got GL in 0.GL position. There we go. GL in 0.GL position. Oh, and you can't see that because I'm putting it right under my face. Okay. In fact, I'm going to go ahead and swizzle all these back up. Frag left corner XY, GL in, GL position ZW. Frag right, frag left, GL ZW. There we go. Still getting errors. Here's hoping that it's a different one. Invalid type and constructor on line 90. I guess we were seeing that before anyway. Okay, line 90. Corner pause. Position plus vec4 arrangement 0. Let's see, arrangement. Yeah, arrangement needs to be arrangement I. See if it's going to let me. Nope, it's not. Not really sure why it's not responding to my recompile shaders. I should have brought more coffee up. Undefined variable frag left corner. Awesome, getting a lot further. Okay, particles geometry. Frag left corner. Vec4. Vec4. Undefined variable field value. So the other thing we have to do, and this was something that really stumped me for a very long time, is that whenever we have our, we have to specify a, what's it called? We have to specify all of our outs for every single vertex that we emit. So we have to specify our V model as a vec4 that's flat. We have to specify our field value. We got to specify our radius and all that stuff. And where we're ultimately going with all of this is once we have a quad that covers the projected radius, we are then going to interpolate along a sphere for it. All right. We're going to interpolate along based on the impact parameter. Okay, well, as you can see, it is now rendering. It is rendering incorrectly. And I think it's hanging my system. I'm not even sure that I'm still able to stream at this point. Probably getting some funny bitrate stuff. So let's cancel that. But this is exciting. It's getting us a lot closer to where we're headed. Now, because this is going to get us a lot closer, but it's also going to, because we're specifying things in world coordinates, let's go ahead and let's check our particle rendering. And here, in our particle rendering, we'll say scale is 1e minus 5. And let's make sure that our radius here is multiplied by our scale. That's grid expand. We want particles expand. And actually, let's go to particle vert. Yeah, it's multiplying by the scale. So let's multiply by 1e minus 5. See if that fixes it. And my stream might drop out while I'm doing this. So it seems clear that something strange is going on with our Z or our W or something. But I think we are in fact getting quads that we want. And I think that pretty much wraps up what I am able to do right now. So I am going to commit my changes. I'm actually going to rename this file. How do I rename this file? I guess I'll save it as something else. We'll save it to particle expand. I'm going to discard the changes to particles.geom. We'll go back over here into shader list, geometry, particle expand. Now let's take a look at all of our diffs, shader objects. All right, looks good. It's got the new compilation changes. So if we run into errors, it'll show something. Yeah. So let's add that one. Blocks, I'm not going to commit now. Grid expand, not going to commit that. Particle expand, going to commit that for sure. Particle frag, yeah, okay. Particle vert, yeah, setting that up for feeding into our geometry shader list. We're adding our geometry shader. Yeah, probably better add the particle rendering one there. And I think the rest of this stuff we don't want. So add first draft particle geometry shader. Ooh, show command output. Files were modified by this hook, shader objects.py. All right, let's take a look. Shader objects. Let's see, shader objects. What's changed? Oh, okay. Oh, yeah, I think it's using a different version of, or a different config to black when I commit through Git and when I save here. I'm not sure how to fix that for VS Code. Okay, now let's update that. And I think that'll do it. I'm going to call it for today, well, for now at least, and come back to this another time in order to fix all the different issues with how we are projecting our spheres. And then we'll add on sampling textures in order to get our SPH kernels for SPH particles. Okay.